For today, it's a review of yesterday where we did things like, that's pi over 4. And so we should be able to tell what the sine of pi over 4 is. I'll do this one. I can know right away that that's a 45, 45, 90, and I know the side ratios. I may not know how long the radius is, but I know the ratios would be 1, 1, and the square root of 2. Does that make sense to you so far? And so if I want the sine of this, which angle is it? There's 3 angles. That one. The one by the center, it's called the central angle. That's the one you use. Sine of that angle, sine is opposite over hypotenuse, 1 over root 2. Now that's pretty much the same as me asking you the sine of 45. But this technique can be used to even find things like the sine of a really big angle, like 150. But I'm not going to call it 150, even though that's an angle that's called coterminal with it. I'm going to call it a whole bunch of pi over, what do you think I'm going to call it? If this is 150, I'm going to call it, what, pi over 6? Not just pi over 6, it's going to be, how many pi over 6s? 5 pi over 6s, because 5 pi over 6s are 30s. 5 30s would be 150. Okay, so that's 5 pi over 6. Here's where 1 pi over 6 would be. Here's where 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. All right, would you please figure out sine and cosine and tangent of 5 pi over 6? Hint, you're probably going to want to put those sides. You're going to probably want to make a right triangle. First of all, you're going to probably want to put in those sides. But how do I know the sides, Mr. Server? Because you know that this is a 30, 60, 90, so you should know the ratios of the sides. All right, I'm going to pause for a second and put you in small groups. So just a quick reiteration of the most common mistake in circle trig is forgetting that if you go in certain directions, then the sides are negative. All right, so this is the 1, the 2, and the square root of 3, but which of those is going in a negative direction? The square root of 3 part. If you're starting here, think about it. Going up like this is a positive direction. Going left, though, that's negative. So that's a negative square root of 3. That will affect your answers. Your answers are going to be ratios, and they include negatives. Row 4, person 4. 1, 2, 3, 4, that's you. What do you think the sine of 5 pi over 6 is?
Sine of 5 pi over 6 would be 1.
Sine is opposite over hypotenuse. You are correct. 1 over 2. Raise your hand if you guys had 1 over 2. Okay, good. Why isn't there any negative? Because I didn't have to use the root 3 side. All right. So then the cosine is adjacent over hypotenuse. Negative root 3 over 2. And last but not least is the tangent. The tangent of 5 pi over 6, TOA, opposite over adjacent, 1 over negative square root of 3. Raise your hand if you are on track with that. You get that. Okay, good. Then without any help at all about drawing where it is and all that stuff, would you please figure out the, let me think, the sine of 5 pi over 4? Sine of 5 pi over 4. This, I can tell you, is going to be consistent. You're going to draw a ton of right triangles. You're always going to want to put in the angles and the sides. And once you have all the angles and all the sides, it'll be easy. Draw the triangle in the right spot with all the angles and all the sides. And then finding the sine will be super easy. It's all about your little supporting picture. When calculus comes along, I asked, so how do you guys want them to do this? Do you want to have them memorize it on this thing called the unit circle? And the answer comes back, just have them draw triangles. Because drawing triangles is the easiest way to do it. Yes, you can memorize these. You can memorize what the sine of 5 pi over 4 is. And it will be slightly faster then. But there's some you can't memorize every possible combination. So, especially when we start using x's and y's for the side lengths instead of like 1s and 2s and square roots of 3, it's better to just draw the triangles. Okay, so how many of you guys were putting your triangle leg right there? Nobody, I hope, because I was doing it wrong on purpose. How many of you are putting your triangle right there? Okay, good. And then this makes what kind of triangle? 30, 60, 90, 45, 45, 90? 45, 45. So this is 1, 1, square root of 2. Chance to make a mistake. Did you remember? -1, -1. Bet you a lot of people forgot already because it's the most common mistake. All right. And then sine is opposite over hypotenuse. This is the opposite. This is the hypotenuse because that's the key angle we care about called the central angle. And then it's -1 over square root of 2. Yes.
Oh, how do you know when to do negatives?
Okay. Think of it this way. If I just gave you an XY chart like this and I said, here's a point. Okay. Would you know that that had a negative? Why? Same exact rules apply. See what I mean? You knew that that had a negative. And in fact, does it have 2 negatives in it? Like this point, something comma something? It does. So if you were to draw that triangle, it would have 2 sides. So let's say I would make a triangle around that. Do you get that this side would be negative and that side would be negative? It's the same exact rules as that. Okay? Yes?
So why wouldn't the hypotenuse be negative?
That's a good question. They had to define the hypotenuse as this radius will never be negative. It's kind of an in-between direction, isn't it? It's not exactly up or down or left or right, okay? So the reason I think they really had to define that is because if you go this way, your part going negative and your part going positive. What are we going to call that? So anyway, you can just know that the radius, or not the radius, it's not the right way to say that. The hypotenuse of your triangle will always be positive. Okay. All right. So I'm hoping you feel like you've got that down. Let's see if you can get some of the weirder ones. The cosine of 11 pi over 6. I'll pause for a second while you give that one a try. I'm hoping you knew that 11 pi over 6 was a whole bunch of these. That's a pi over 6. That's 2 pi over 6. When you get stuck, count them up. That's 3 pi over 6, 4, 5, 6. Once you go that far, it's going to be easy. 7, 8, 9 pi over 6. You might be like, but couldn't that reduce? Yes, but I don't want it to. I want to just keep counting with pi over 6s. 10 and 11 pi over 6. I'll use a different color. It's that one. And so then I draw my triangle this way. Now, there is a potential screw up right at that moment. Do you get, you could have drawn a triangle that way, but don't ever do that. So how do you decide which way to go? You always, when you're done, like going out on the little spoke, okay, you always go to the x-axis from there. So if I'm here, I go to the x-axis. If I was here, again, I go to the x-axis, just like that. As opposed to, you could be theoretically going like that, but it'll screw everything up. Don't do that. Always drop to the x-axis. Okay, so I'm going to take this one, and I'm going to make my right triangle, And a pi over 6 is like 30, right? So that's 30. And I'm not going to memorize or rememorize this as the pi over 6. This is 60, which would be pi over 3. And that's a 90, which is pi over 2 triangle. I'm still calling it the 30, 60, 90. So some people that say, once you're better at trig, you just only think in radians. I'm calling baloney on that one because you don't call it a 30, 60, 90. You don't call it a pi over 2, pi over 3, pi over 2. You know, like, you don't do that. You stick with 30, 60, 90. There are some things that degrees are better at because you've already got it memorized. 1, 2, square root of 3. Is any of those negative? That should be your first question to yourself. Yes, that one was negative. If you forgot that, it actually didn't hurt you this time because cosine was adjacent over hypotenuse and you would have never had a chance to screw up that. So root 3 over 2. Okay. Now, I just want you and your partner to, like, I totally get that some of you guys are going to be able to go, oh, 60 degrees, that's pi over 3. And some of you guys are going to be really good at that, and others of you are like, how did you do that? I want you and your partner to get a method that would work even if I change this to 65 degrees. How would I change this to radians? And I know that one's pi over 3, but how do you get that? And if your way works, you should be able to change 65 degrees into radians also. Now, if you already know. I want to see how many groups can figure this out. But if you don't know, I'll show you how in a minute. Okay? So figure out how to change degrees into radians in a consistent way. It'll always work. Okay, I'm going to give a second to try that one. All right, so we're going to multiply by pi over 180. That is a conversion factor. It's called a fact. There is pi radians goes with 100 degrees. Or sorry, 180 degrees. So this one ends up being 60 degrees pi over 180 degrees, but really something cancels, right? Degrees cancel. So then can you reduce 60 over 180? Sure, it's pi over 3, and there it is. Some people just have it memorized already. But you can kind of check it quick by just going, remember, pi is supposed to be 180. 180 divided by 3, 60. It works. All right, so this one, 65 pi over 180. That's your answer. It's not a very satisfying, clean number, but that's the answer. All right, let's do another one like that. I want you to get the point that this is a conversion that will work with inches and feet too. If I had 383 inches, would you please change that into feet for me by using a conversion factor? Compare with the kid next to you, see if you guys are doing the same factor. Why'd I put inches on the bottom? So then inches cancel, and then I have feet. I've changed it from inches to feet. And the answer is 383 divided by 12, whatever that is, and it looks like you may have it. What'd you get?
31.9.
Anybody verify 31.9? Okay, good. I just changed it into feet. This will work for changing different kind of money, like dollars into pesos. It'll work for changing so many different things. But what we care about right now is degrees and radians. So let's do one with radians. Let's say that you have 2 pi over 3, and you want to change that to degrees. Right away, you just break out a conversion factor, and that pi gives you a clue. What's our fact again? 1 foot is 12 inches. No, different fact. What are our facts? What equals what? Pi equals 180. Which one should go on top? 180 degrees, pi, and now the pi's can cancel. 2 times 180 over 3. That's like 360 divided by 3. What is 360 divided by 3? 120. There we go. And it's in degrees now. Okay, now we have to take this one step further. I am approximately 20 feet from the door. All right? I can get there in 2 seconds. Ready? See if I can drop my iPad. 1, 2. There, got there. Okay. So, would you see how fast I was going in miles per hour? I went 20 feet in 2 seconds. It's actually supposed to be insanely scary how quickly a person can go from 20 feet away from you to like right on top of you, so to speak, if they're wanting to mug you or sneak up on you or whatever. They can close that distance at 20 feet super quick. You can't almost react, and they're on top of you. It's very little time. So in self-defense classes, they're going to basically make you think about how close somebody is, because once they get within a certain distance, are not going to have any time to react. So how fast was I going? I wasn't even going light speed there. Didn't have to go very fast, because 20 feet, you can cover that pretty quick. Well, you're going to multiply by a few things, right? Who knows a fact, a conversion factor, that would be handy right here? Yes?
5,280
Yes, 5280 ft over 1 mile. Actually, miles on the top and feet on the bottom. How do I know that it goes that way? Because the feet will cancel this way. And by the way, that fact, 5,280, is a number you're going to have to use in this class on more than one test, and it is not provided. I sometimes marvel that we won't give you that. Well, some people will happily give you a bunch of formulas, but they won't give you that number. So anyway, memorize it, 5,280. I'm a believer in memorizing a few things. Because if you take that argument of never memorize things too far, yeah, you can look things up, but good luck when you're in the boardroom and you're looking up 7 times 8. They're going to be like, this is our president and he can't do 7 times 8? Hey, there's certain things you expected to know. Okay. 5,280 feet in a mile. I know it's kind of a pain. I wish we just used the metric system. I really do. I don't hate our system or anything, but it's like metric, if you haven't figured this out, it's a lot easier. So much easier. Everything's either a 10 or 100 or 1,000. It's all nice round numbers. But we have our system, and it's the way it is. We've had like 2 or 3 different presidents promise that they were going to change us over to the metric system, and it never happens. I don't know what it is. I wonder where that log jam is that they can't ever get it through. I know one of the things is money. Why? Why would it cost money? Every sign in the whole United States would have to be changed. Think about that. Not every sign, but every speed sign, every distance sign. You know what I mean? There's a lot of signs. In fact, I bet you anything, the Sign Manufacturers Association of America, they're probably advocating really hard for change to the metric system. We'll make tons of money on the signs.
Aren't cars also default to miles per hour?
But the reason that the cars are in miles per hour is only because we have that system. So it's like a chicken or egg thing, right? The cars are their speedometers are in miles per hour, but if you look on a lot of cars, they do have kilometers per hour on them. I don't know if that's because just in case we switch to the metric system, or so they can sell them in Europe, or what, but. All right, so this shouldn't have been too hard for you. I got miles per second now, and by now you should have figured out that you should probably put seconds on the top so it'll cancel, right? Did anybody go direct and use 3,600? I'll be impressed if you did. Did anybody do that? All right, a couple people. Some of you guys, I get this. You know one of these facts in your head. You know that it's 60 seconds in 1 minute, and that'd be fine. You just got to do it again then to change minutes. And you'd change it by putting minutes here. And what's one last fact that gets us there? 60 minutes in 1 hour. And they could have just gone directly by doing 60 times 60 is 3,600. But and yay, minutes have canceled. Look, I'm careful with my units, and I got miles per hour. And you could multiply across the top, and then multiply across the bottom, and then divide them. And would you please do that? I want to know how fast I was going. Got it?
Yeah.
What'd you get?
6.82 miles per hour.
You think there's anybody faster than that? Oh, yes. Fastest human goes about 25 miles per hour. But I would say I don't think anybody could go 25 miles per hour that quick, because you got to start at 0. You know what I'm saying? So it'd be really hard to average 25 miles per hour, because you'd have to actually end up with a top speed a lot higher than 25. So anyway, all I guess I'm trying to say is at 7 miles per hour that I did there, you probably could have somebody at least go double that speed, which means it would be 1 second. So literally 1/1000, they could go from 20 feet away from you to like right next to you. Okay, so a saw spinning at 2,000 RPM. That isn't very good. I better write that as something else. 2,000 rotations per 1 minute. A lot of people know that RPM means rotations per minute, but you might not have thought to write it this way. If a saw blade is spinning at 2,000 rotations per minute, let's say that there's a little, I don't know, piece of, maybe we paint one of the saw's blades, just a little touch of red on the end of it. Then that will spin, right? And it'll go really fast. Well, how fast will it go? Would you please figure it out? There's one question you need to ask me still. And that's a good question. No, I wasn't even thinking of that one. I was thinking in my head, of course they'll do miles per hour, so I didn't say that. So let's do it in miles per hour. But there's one more question you actually have to ask, otherwise you can't tell.
What's the radius of the part?
Correct, the radius of the saw blade. So here's the saw blade. Here's like the little teeth on the outside. Okay. That's going to be 8 inches. Oh, that's a pain. Because now I have inches mixed in with feet and a mile and all that stuff. You know what I'm talking about? So how about we make it 12 inches? So therefore it's 1 foot. At least now I have feet going in the same conversion factor that I know. 5,000 and what is that again? 5,280. Good. Everybody change 2,000 rotations per minute, or RPMs, into, if it's a 1 foot radius, figure out what to multiply by to get yourself into miles per hour. One last thought. Is it traveling 1 foot every time it goes around? No. That means you're going to have to know a formula about circles. And it's not the area formula that everybody knows, pi r squared. Who's got the circumference of a circle formula memorized? 2 pi r is an okay one. Very good. 2 pi r would work. Or, who's got the shorter one? Pi d. Very good. Again, some people would say, well, you can just look it up. Do you want to look up everything? It takes a long time. You should memorize the circumference. Besides, things like the ACT, you can't just look it up. You bust out your smartwatch and look it up, you're going to the ACT jail. Okay, work with a partner, figure out how many miles per hour that little saw tooth would be going. All right, I know you're going to have problems with the rotation thing. Some of you guys are going to get it right, but some of you are going to mess up the rotation thing. I'm going to help with this. One rotation. Why did I just do that? Because it'll cancel rotations. What is one rotation? One rotation is also known as a circumference. And so the circumference is what? 2 pi r. But wait, I know r. What is the radius? 1 foot. 2 times pi times 1, which is 2 pi. And we got to have units. Feet. Now I have rotations canceled. And good question. When it's all done, if I said you went like 16 pi feet, that's going to be kind of confusing. So let's use 3.14 for pi and get the final answer as how fast is this thing going in miles per hour. Basically what you have on a saw blade like that is a little electric car. Because if you like let it go on a table, it would go insanely fast. Instead of cutting the wood, it would just dig into the wood and it would just fly out of your hand, go shoo, really, really fast. Well, let's see exactly how fast. I hope you multiplied by 5,280 feet, and that would be 1 mile. And now I'm in miles per minute, and then I gotta get the minutes out of there, so I put minutes up here, and I think, what minute? Oh yeah, there's 60 minutes in 1 hour, so then minutes are gone, and now I have all of that divided by 5,280. In the back, KF, what did you get? 142.7. Raise your hand if you had 142.7. Okay, awesome. But what's super important is the units. Could you read me your units? Yes. That's pretty typical. These saw blades are spinning at like hundreds of miles per hour. They're going really fast. But that's turning a rotation into a normal speed, which is more of a linear speed, miles per hour, straight line speed. Okay, last thought is coterminal. This spot right here has 2 names. I could have got there this way, which is 3 what's? Remember, this is pi. Think in radians. Don't think 390s. That would be 270. That's degrees. I want radians. 3 sets of pi over 2. Because that's 1 pi over 2. This one would be 2 pi over 2. But wait, that's the same as pi. And this would be 3 pi over 2. Raise your hand if you had 3 pi over 2. Awesome. What's another way to say that spot? Yes, 270 degrees is another way to say that spot. Now there's 2 more. Yes, but just because it isn't simplified doesn't make it different. It just means it's not simplified. So I hear you. 6 pi over 4 is different than 3 pi over 2, but it's just a simplification issue. I want something completely different. Yes? Yes, negative pi over 2. Because there's different directions you can go. And last, let's do it with the negative degrees. Negative 90. 4 names for the same spot. Those things are called coterminal angles. Co meaning they share the same. Terminal means where you stop. Terminal. A terminal. Yeah, I'm not going to go into the depressing kind of terminal. If your trip terminates, that means that you stopped moving, right? All right, terminate means stop. All right, so let's see if you really caught that. Give me 3 angles coterminal to 5 pi over 4. If I were you, I'd always start by drawing it so you kind of know where you are. That's 5 sets of pi over 4. Work with your partner to figure out 3 other ways to say 5 pi over 4. Pausing. Okay. Here's where 5 pi over 4 is. And that means negative 3 pi over 4 would have worked. Raise your hand if you guys had that one. Good. And also, both of those in degrees. This would be negative 135 degrees. If you don't remember how to change that over, you could just go negative 3 pi over 4 and change it using 180 over pi. You know what I mean? You could have just converted it. Then it'd be degrees. There's 2 of my answers. I'm going to give you one that I doubt anybody even thought of. I'm not just going to do this in degrees. That would have been understandable and easy. Like, that's not a bad idea. It'd be 180 plus 45. It'd be 225. But that's not what I'm going to do. I'm going to give you this answer. $585 degrees. Do you get that would stop in the same spot? The first 360 would just bring you all the way back to where you started. And then you add another 225 to that, and you end up stopping in the same spot. So you can go past it and come back. Use that same technique to tell me, I know that's 30 degrees. Give me a really big degree answer. That would be the same. Talk to your partner, see what you think the really big degree answer would be. Not the negative one. Ooh, fancy. Some people went 360 plus 360, which would be what? Plus the 30, which would make 750. Or you could have just done 360 plus the 30 makes 390. Or you could have done negative 300. And I haven't even changed to radians yet. You get to every one of those could have been changed to radians too. So coterminal is actually an impossible job to find all the coterminal angles because it's an infinite number. Yay, you know everything. So, your homework for tonight is on day, well, it's listed as today's date, which is the 25th. You find the file, it says February 25th on it. I'll pull it up on the screen here in a second. Okay, so unfortunately I can't pull this up on the iPad, but for those of you that are at home, when you find the homework, it says 12.1 day 2, and you scroll down to, can you guys help me which page this is on in the notes? Page 10 in your notes. It'll say day 2, which quadrant on top. All right, we're gonna do the, you get that there's 4 on that page that are circled? Do the 4 circled ones. I feel like this is too easy, so we're going to skip the whole next page. But then you're going to go to the black page that says, in the yo-yo trick around the world, do problem 52. And 53. Nope, not 53. We're going to do 52 and 55. This one. I think if I remember right, I want to get you used to Ferris wheels. We do a fair number of Ferris wheel questions later because they have these nice little wedges in them that makes them look kind of like the unit circle. And one last review question, problem 60. Just problem 60. Remember, if theta is pi, that can be confusing. Remember, pi is like 180, right? So problem 60 along with the others. And that's all I have for you for today.